So the second half of the practice test has a bit more algebra, I think, than the first half. And it has questions that if you don't know what they're asking, you won't be able to do. Question 8 you do in college algebra. To find the average rate of change, that implies to find the slope of a line that connects 2 points on a graph. And in problem 8, I give you a function and I give you 2 values of x and ask you to find the average rate of change. What's implied by this is to find the slope of the line that connects 2 points that have the x coordinates of 1 and 2. In order to find the average rate of change, I need to get the y coordinates of the points, and those aren't given to me. So I'm going to find the y coordinate that corresponds to each of the values of x by plugging the value that's given in for x. The first y I get by doing 1 cubed plus 5 times 1. That's going to be 1 plus 5, which is 6. And the second y I get by plugging 2 for x, which is going to be 2 cubed plus 5 times 2, which is going to be 8 plus 10, which is 18. So I've created 2 points, and the average rate of change is simply just the slope of the line that connects those 2 points. When I go to write my answer, I think I'm just going to put a number in a box. To do a slope of a line, you do y coordinate of the second point minus y coordinate of the first point, divided by x coordinate of the second point minus x coordinate of the first point. This comes out to 12 over 1. My answer to problem 8, the average rate of change, is just going to be the number 12. Nine wants me to use the definition of a derivative to find the derivative. And I need to create 2 points. The first point is going to be x, comma, and then just whatever the function is, in this case x squared plus 3. The second point is going to be x plus h, comma, whatever you get when you plug in x plus h into the function. So I need to find f of x plus h. F of x plus h is going to be that x changed to x plus h, so x plus h squared plus 3. I did this a ton in the videos. Once I got to an x plus h squared, I just wrote down what it equaled to. X plus h squared is x squared plus 2xh plus h squared. You should have that memorized. And if you're lucky enough to get to use a note card, you should just have that on your note card. So this I did in the video a bunch of times, and you should absolutely have memorized, if you don't get to use a note card, that x plus h squared is x squared plus 2xh plus h squared. It'll save you a lot of time on the test. So the y coordinate of f of x plus h is x plus h squared plus 3. I wrote out the x plus h squared and left the plus 3. So the y coordinate of the second point is x squared plus 2xh plus h squared plus 3. Now I'm going to find the derivative. The derivative f prime of x equals the limit as h goes to 0. I just find the slope of the line that connects those 2 points. The second y is x squared plus 2xh plus h squared plus 3. The second y is x squared plus 3. That's y2y minus y1. In the denominator, I need x2 minus x1. I don't know why I put so many parentheses in, because most of the parentheses I wrote there weren't necessary, but I put them in, and it's not a bad thing that I did. Let me try to squeeze this algebra in. So f prime of x equals the limit as h goes to 0. I'm going to clean up the numerator. Here, the first parentheses I'm just going to drop, and I'm not going to change anything. I'm going to write x squared plus 2xh plus h squared plus 3. In the second parentheses, when I drop it, it's going to turn into a minus x squared and a minus 3, because the minus impacts both the x squared and the 3. And in the denominator, I'm just going to drop both the parentheses, leaving the minus sign in front of the x. Now I'm going to cancel a bit. The x squareds in the numerator cancel, the 3's in the numerator cancel, the x's in the denominator cancel. And this is going to give me f prime of x equals the limit as h goes to 0. What didn't cancel in the numerator is 2xh plus h squared, and what didn't cancel in the denominator is an h. I'm now going to factor out an h from the numerator because there's a common factor of an h. And when I factor out that h from the numerator, from that piece I'm left with a 2x because I took its h away. This plus sign stays. Where I had h squared, I took out one of the h's. I'm left with one of the h's. I'll leave the denominator alone. And now I'm going to cancel the h in front of the parentheses with the h in the denominator. And that's going to reduce this to f prime of x equals the limit as h goes to 0 of just 2x plus h. The fraction is gone. Most of the h's are gone. Now I'm going to plug in 0 for h. And I'm going to stop writing the word limit as soon as I plug that 0 in. So it's going to be 2x plus 0, and it's just 2x. My answer to part A, I'm going to write f prime of x equals to 2x. Done with the hard part of number 9. Part B just wants me to do f prime of 5. To do f prime of 5, I'm just going to plug a 5 in for the x's. So for part B, I have a formula for f prime for any x, and I just want to change that x to 5. F prime of 5 is just going to be 2 times 5. For my answer, I could just write the number 10, or I can write the problem next to the answer. It doesn't really matter what you do. All right, so that's an ugly question. Not as ugly as 10. 10 wants me to find a formula for the slope of the tangent line. That's the same as saying find the derivative, because a derivative is a formula for the slope of the tangent line. In order to find a derivative, I need to have 2 points. The first point is always x, comma, the right-hand side of the function. The second point is always x plus h, comma, what you get when you change any x in the function to x plus h. And this one I can do without doing any side work. To find f of x plus h, I just change that x to an x plus h. Now I'm going to do the derivative. The derivative, f prime of x, which is the formula to find the slope of the tangent line, is the limit as h goes to 0 of y2, which is 2 over x plus h, minus y1, which is 2 over x. I don't really need parentheses at all in this problem, so I'm not going to put them in. Divided by x2 minus x1. In the numerator, I need to get a common denominator. I'm going to multiply the left fraction by x over x. And I'm going to multiply the right fraction by x plus h over x plus h. I kind of did a fancy multiplying with this fraction just to make the denominators look more alike. In the denominator, the x's are going to cancel. So let me try to clean this up. What I'm going to have right now is f prime of x equals the limit as h goes to 0, and this numerator is going to be 2x minus 2 times x plus h over the common denominator, x times x plus h, all divided by h. Let me clean up that numerator by clearing the parentheses. So I'm going to get f prime of x equals the limit as h goes to 0, and this is going to be 2x minus, and I'm going to go minus 2 times x, which is minus 2x, and minus 2 times h, which is minus 2h, over x times x plus h. And instead of writing this 3-leveled fraction, I'm going to change to this divide by h. As a fraction, I'm going to change it to a division sign. Now in the numerator, the 2x's cancel, and I'm going to change this division into a multiplication by a fraction. You can divide or multiply by the reciprocal, and those are equal to each other. So I'm going to rewrite this as f prime of x equals the limit as h goes to 0, and then in the numerator of the fraction I have a minus 2h. In the denominator I have an x times an x plus h, And instead of writing divided by h, I'm going to write times 1 over h, because dividing by a number is the same as multiplying by its reciprocal. This is a good thing because now this h and that h will cancel, and this will get me to f prime of x equals the limit as h approaches 0 of negative 2 over x times x plus h. This whole piece doesn't need to be considered anymore because it's just a 1. At this point, I can plug in 0 for h because I'll get a nice answer and I won't get a 0 in the denominator. So now I'm going to change the x to 0, or the h to 0, and get f prime of x equals negative 2 over x times x plus 0, which is going to be negative 2 over x times x. And that's going to be negative 2 over x squared. That's going to be the answer to part A of number 10. That's the formula for the slope of a tangent line. F prime of x, the derivative, gives me the slope of the tangent line. And let me write it here. I'll write it in my Christmas colors because it's actually Christmas Eve morning. So this is f prime of x is negative 2 over x squared. So done with a chunk of algebra. That's the worst algebra on the whole test. And I have a derivative. The next part, part B, wants me to find an equation for a tangent line. And to find an equation for any line, I need a point and I need a slope. And the only thing I have is the x-coordinate of a point. I need to get 2 bits of information. I need to get the slope, and slopes you get by using the derivative. So I'm going to find the slope by using the derivative, and I'm going to plug 3 in for x. I'm going to go f prime of 3 as negative 2 over 3 squared. That's going to be negative 2 over 9. So the slope I'm going to use is m equal to negative 2 over 9th. I also need a point. I get y-coordinates of points by using the original function. So I'm going to get the y-coordinate of the point. I'm going to say y equals, and I'm going to get that y by plugging in 3 for the x, and that's going to give me 2/3. Now that I have both a point and a slope, I can use the formula y minus y1 equals m times x minus x1 to get the equation that I'm looking for. So I'm going to go y minus 2/3 equals negative 2/9 times x minus 3. Yuck. This gives me y minus 2/3 equals, I'm going to go minus 2/9 times x, which is minus 2/9 x. And then minus 2/9 times minus 3. I'm going to do that on my calculator. So on my calculator, I'm going to go parentheses minus 2 divided by 9. That's the minus 2/9. And then parentheses minus 3. That's the times minus 3. I'm going to hit enter, and then math, enter, enter. And I get positive 2/3. I knew it was going to be positive because I multiplied 2 negatives. I should get a positive. And I kind of knew it was going to be 2/3. When I did this multiplication here, this 9 and that 3 will cancel. The 3 will turn into actually a negative 1. The 9 will turn into a 3. And you get negative 2 times negative 1, which is positive 2 over 3. Easier for me to do on my calculator. I'm going to finish solving for y and get my answer by adding 2/3 to both sides. This is going to give me y equals minus 2/9 x plus 4/3. One more problem left to do, and I made the problem a little bit easier on the test than it is on the practice test. So let me make that, well, let me do it the long way. I think on the test, it looks like this. It says, it gives you an equation like this, and it says, given, it gives you the derivative. So let me change number 11 to say this. A toy rocket is launched straight up so that its height, s, in meters, should say its height, s of t, it might be easier for you to understand that. Its height, s of t, in meters at time t seconds is given by the height equals negative 2 times the time squared plus 20t, And to make your work easier, the derivative of this function is negative 4t plus 20. The instructions are going to say just find s prime of 2 and interpret your answer. And that's all I'm going to ask. And I'll go ahead and change this problem so that if you open this problem up, it won't no longer have a part A and a part B. It'll probably just have not even a part A. This will just say, it'll just kind of all fit together. But you're going to be asked to find s prime of a number, or evaluate the derivative at a number. I'm going to give you the derivative. So to do s prime of 2, I'm going to take and plug in 2 for t and get negative 4 times 2 plus 20. That's going to be negative 8 plus 20. That's going to be 12. So part of the answer to this question, s prime of t, is 12. And hopefully you remember that for these position functions, the derivative gives you the velocity. It gives you the velocity in distance per time. And the distance is measured in meters. The time is measured in seconds. So this s prime of 2 means the rocket speed, I'm going to say velocity, is 12 meters per second. Because this number is positive, the rocket is still getting higher. If the number was negative, the rocket would be going back down towards the ground, but you don't need to put that comment in. So the last problem on the practice test is going to be tweaked slightly. I'll make sure and change it on your in-class practice test to be like this, and I'll go ahead and change it so when you open this up yourself, it might look a little bit different. So that's everything. If you can do all 11 problems between the two practice tests, should be perfectly fine for the test. We have that extra practice test on my webpage too that you need to practice, because that, you know, they should be the same. If you do all the problems on both practice tests, you should be completely ready for the test.